Across the United States, more than 100 billion cardboard boxes are used every single year. From Amazon deliveries on your doorstep, to food packaging in grocery stores, to the shipping crates that move America's economy, almost everything is touched by cardboard. But what most people don't know is that over 90% of all cardboard in America is recycled, making it one of the most successful recycling systems in the modern world. And behind that achievement are gigantic facilities, some the size of entire neighborhoods, where mountains of paper waste are transformed back into brand new packaging. Today we're taking you inside one of the largest cardboard recycling plants in America, where millions of tons of waste paper arrive, are shredded, pulped, cleaned, pressed, dried, and reborn as fresh cardboard, ready to start the cycle all over again. But before we dive in, don't forget to like this video, subscribe, and hit the bell icon so you never miss our deep dive documentaries into the hidden industries powering our world. Cardboard might seem simple, just brown paper, but its story stretches back nearly 150 years. In 1871, American inventor Albert Jones patented the first corrugated paper used to protect glass bottles. Soon after, corrugated cardboard evolved into the shipping boxes we know today. By the early 1900s, factories across the US produced millions of boxes for railroads and growing retail industries. But as America exploded in population, consumer goods, and nationwide shipping networks, cardboard waste became a massive problem. By the 1960s, landfills were overflowing with paper packaging. That's when large-scale recycling began. Cities launched curbside programs, grocery stores compacted boxes instead of throwing them away. And by the 1980s, cardboard had become the most recycled material in the country. Today, the recycling rate is astonishing. More than 32 million tons of cardboard and paper are recycled in America every year. And at the heart of this system are the giant plants we're about to explore. Every day, trucks loaded with old corrugated containers, known in the industry as OCC, arrive from across the region. Some come from supermarkets, loaded with flattened produce boxes. Some come from big box retailers, packed tight after nightly restocking. Some come from households, collected from curbside bins across entire cities. At the unloading zone, mountains of cardboard rise stories high, forming hills of material waiting to be reborn. Forklifts, wheel loaders, and giant bulldozers push the waste into towering piles. These facilities often handle up to 2,000 tons per day. That's the equivalent of processing an entire football stadium filled with cardboard every 24 hours. But this cardboard can't be recycled yet. Plastic tapes, food contamination, staples, wooden debris, packing foam, all of this must be removed, and that's where the journey begins. Inside the plant, a web of conveyor belts carries the waste paper upward into the sorting line. Workers and machines team up in one of the fastest and most critical steps of the entire process. Human workers stand along high-speed belts, removing anything that doesn't belong. Their job is intense. A single worker may process 4-8 tons of material per hour. Next, high-tech machines take over. By the time the cardboard exits the sorting line, it is nearly pure, clean enough for pulping. The clean paper is fed into giant conveyors, moving toward the heart of the recycling plant, the pulper. The pulper is where the magic happens. Imagine a steel tank the size of a small swimming pool, filled with rotating blades, powerful enough to tear paper apart on a molecular level. Workers release bales of sorted cardboard into the pulper, where it mixes with warm water. The blades rip and churn the material, turning it into a thick slurry called paper pulp. The transformation takes just a few minutes, but the chemistry behind it has been refined over decades. Cardboard is made from cellulose fibers, long strands from trees. When water penetrates the fibers, the hydrogen bonds loosen. Mechanical force breaks the structure, freeing the fibers to be reused. Screens inside the pulper trap the unwanted materials, leaving behind a smooth, oatmeal-like pulp. This pulp will become brand new cardboard, but not before it takes a trip through the most advanced cleaning systems in the industry. The pulp is pumped through a system of machines designed to refine and clean the mixture at microscopic levels. Finally, disc refiners gently brush the fibers, improving their bonding ability for stronger cardboard. By the end of this stage, what began as dirty waste is now a clean, silky pulp ready to become paper once again. This is the dramatic heart of the plant. The paper machine, often hundreds of feet long, it consists of 3 main systems: the forming section, the press section, and the drying section. The pulp mixture, now 99% water and 1% fiber, is poured onto a moving mesh screen called the wire. As it travels, water drains away. Vibrations shake the fibers into alignment. A mat of future cardboard begins to appear. For the first time, the material looks like real paper. The wet sheet moves between massive steel rollers. These rollers squeeze out more water under extreme pressure, up to 1,000 psi. After pressing, the sheet is still too wet, but its thickness and structure are now fixed. This is where the real transformation happens. The paper passes through rows of steam-heated cylinders, some over 6 feet in diameter, reaching temperatures of 250 degrees Fahrenheit, 120 degrees Celsius. As moisture evaporates, the sheet strengthens and shrinks slightly, becoming stiff, durable, and ready for corrugation. By the time it leaves the drying section, the sheet is a ribbon of smooth paper traveling at speeds over 3,000 feet per minute. This long ribbon is either rolled into massive reels or sent directly to the corrugator. Stacks of fresh cardboard are bundled, strapped, and moved to storage or shipped to customers the same day. The process is continuous. Some plants produce up to 12 miles of cardboard every hour. From here, they're printed, folded, glued, and turned into the recognizable boxes Americans use every single day. In fact, many boxes you receive from online shopping were probably a cereal box or newspaper just weeks earlier. If you enjoyed this journey inside the supergiant cardboard recycling plant, make sure to like, subscribe, and hit the bell so you never miss our next deep dive into the incredible processes that keep our world running. Every year, America throws away more than 10 million tons of glass bottles and jars. But what if we told you that mountain of broken glass can be reborn into something soft, light, and incredibly powerful? Welcome to the supergiant recycled glass wool plant, where discarded glass gets a second life as one of the world's most effective thermal insulation materials. From molten furnaces glowing at 1400 degrees Celsius to hair-thin fibers spun faster than a jet engine turbine, this is the mind-blowing transformation of recycled glass into soft, fluffy insulation that keeps America warm, efficient, and sustainable. Glass is one of the most recyclable materials on Earth. It can be melted and reused endlessly without losing quality. Yet in the US, nearly 1/3 of all glass waste still ends up in landfills. That's where plants like this one come in. Massive recycling and manufacturing complexes, stretching over 40 acres, combining recycling, refining, and insulation production under one roof. At first glance, it looks like any industrial site. Conveyors, silos, furnaces, endless smokestacks. But what happens inside is a masterpiece of engineering and sustainability. Every day, hundreds of recycling trucks arrive at the facility, loaded with crushed glass from homes, restaurants, and factories across the region. The operation runs 24/7, turning what was once waste into gold for the energy-efficient future. The journey begins in the sorting hall, where glass waste is dumped into massive hoppers. Here it's a chaotic mix: green beer bottles, clear jars, brown containers, even bits of porcelain and metal caps. To transform this into usable material, precision is key. Giant vibrating screens shake the material, separating large pieces from fine dust. Next, powerful magnets remove metals like steel or aluminum. Optical sorting systems, guided by AI-powered cameras, scan thousands of glass fragments per second, identifying colors and compositions. Air jets then blow unwanted pieces off the conveyor. It's like a laser orchestra, sorting 20 tons of glass every minute. What remains is clean cullet, tiny pure shards of glass ready to be reborn. And the numbers are staggering. Each ton of recycled glass used in production saves over 1.2 tons of raw materials, reduces energy consumption by 30%, and prevents hundreds of kilograms of CO2 emissions. Sustainability isn't just a slogan here, it's built into every step. From the sorting line, cullet travels on long conveyor belts to the melting furnaces, the fiery heart of the plant. Each furnace is as long as a passenger jet, burning day and night at temperatures over 1,100 degrees Celsius. Here, recycled glass mixes with natural materials like silica sand for structure, soda ash to lower melting temperature, limestone to improve durability, and tiny amounts of boron for thermal resistance. As the mix heats up, it transforms into a glowing, honey-like molten glass, swirling and bubbling under flames of natural gas and oxygen. The sound inside the furnace hall is like a living creature, a deep roar that never sleeps. Operators in control rooms monitor the chemistry, adjusting oxygen flow and temperature to ensure perfect melting. Because even a few degrees too hot or too cold can ruin an entire batch. In one day, this plant melts over 500 tons of glass, enough to insulate thousands of homes. Now comes the magic, turning liquid glass into something softer than cotton. The molten glass flows through platinum nozzles into high-speed spinning wheels, rotating at over 6,000 RPM. As the glass hits the edge of these spinners, centrifugal force flings it outward, stretching it into hair-thin fibers, some just 1/1/7 the thickness of a human hair. Jets of hot air shape and carry these fibers downward through a tall forming chamber, a blizzard of glowing threads floating like snow. Within seconds, molten glass becomes a soft, tangled web of fibers, the foundation of glass wool insulation. It's mesmerizing. Fire transformed into softness, strength, and silence. The chamber's airflow and humidity are precisely controlled to ensure the fibers interlock perfectly. Robotic arms continuously spread the mat to maintain uniform density. Freshly spun glass fibers alone are fragile. To give them structure and resilience, they're coated with a binder resin, a plant-based adhesive that holds fibers together. Older generations used formaldehyde-based binders, but modern eco-plants in America have switched to biopolymers and sugar-derived resins, reducing emissions and odor. As the fiber mat moves along the conveyor, automated sprayers coat it evenly. Then it passes through a curing oven heated to around 250 degrees Celsius, 480 degrees Fahrenheit. Inside, the binder hardens, bonding the fibers into a flexible, springy mat that can bend, compress, and bounce back into shape. By the time it exits the oven, what started as molten glass now feels like soft wool, warm, light, and ready to protect buildings from heat and noise. From the curing line, the continuous mat is trimmed by precision lasers and cut into standard sizes. Some are rolled into compact bundles for home insulation. Others are cut into rigid panels for industrial applications, power plants, data centers, or high-rise towers. The rolls are then compressed by automated packing systems. Here's where the genius of glass wool shines. It can compress up to 10 times its original volume without losing performance. That means more material per truckload and fewer emissions during transport. High-speed robots seal each roll in airtight, recyclable plastic film. Labels are printed automatically, showing density, R value, insulation performance, and batch codes for traceability. Finally, pallets of finished insulation travel down conveyors toward massive warehouses, ready to be shipped across America. Each roll carries the story of sustainability, born from waste, forged by fire, and destined to save energy for decades. Before any product leaves the factory, it must pass through a gauntlet of quality control tests. In the acoustic lab, technicians measure how well the insulation blocks sound waves, a crucial feature for schools and offices. In the thermal lab, samples are placed between heated plates to test their resistance to heat flow. The higher the R value, the better the insulation. And in the compression lab, powerful hydraulic presses squeeze the material to ensure it rebounds to full shape, every single time. Even color and fiber uniformity are scanned by AI systems, comparing each roll to reference standards. Only after passing every test does a batch earn its ENERGY STAR certified label. Most people never see insulation. It hides behind walls, underfloors, and above ceilings, yet it's one of the unsung heroes of modern energy conservation. By installing glass wool insulation, American homes save billions of kilowatt-hours of electricity every year, reducing heating and cooling costs by up to 40%. Over its lifetime, 1 ton of glass wool saves more than 500 times the energy used to make it. That's the power of recycling at scale, turning trash into tools for a sustainable future. At this plant, sustainability doesn't end with recycled glass. Even the heat from furnaces is recovered through heat exchangers to warm nearby offices and melt new batches of cullet. Dust from fiber formation is captured by filtration towers and reintroduced into the melt. Nothing goes to waste. If you enjoyed this journey inside the world of industrial recycling, don't forget to hit like, subscribe, and tap the bell icon so you'll never miss our next exploration into the hidden factories that power our planet. Thanks for watching, and see you in the next adventure. Today, we're taking you inside America's supergiant gold recycling plants, where mountains of e-waste are transformed into pure, gleaming gold. For most people, electronic waste or e-waste is just junk. But hidden inside these discarded gadgets is a fortune, tiny traces of gold. In fact, a single ton of old circuit boards contains more gold than a ton of ore mined from the earth. Before we dive into this mind-blowing process, don't forget to like, subscribe, and hit the notification bell so you never miss our deep dives into the hidden worlds of global industries. For decades, people threw away old radios, televisions, and the first computers without a second thought. Back in the 1960s and 70s, few realized that inside these machines, on their green printed circuit boards, lay traces of one of the world's most valuable metals, gold. At the time, these boards were simply considered electronic trash. It wasn't until the boom of personal computers and mobile phones in the 1980s and 90s that the hidden value began to attract attention. Millions of circuit boards were being discarded every year, and scientists started experimenting with ways to recover the precious gold hidden in their thin layers and connectors. Early methods were crude and dangerous, often involving toxic chemicals like cyanide or mercury. Still, the realization had been made: electronic waste could be richer than natural ore. By the 2000s, with the explosion of smartphones and the internet, mountains of e-waste were piling up worldwide. Governments in the US and Europe introduced new regulations pushing companies to recycle responsibly. High-tech plants were developed using shredding, smelting, and electrolysis to safely recover gold. For the first time, recycling gold from PCBs became an industrial process, not just an experimental idea. The journey begins in massive collection centers across the US. Old computers, servers, cell phones, televisions, and other devices pour in by the truckload. Workers and machines sort through this mountain of e-waste, separating plastics, steel casings, and valuable electronic components. The focus is on printed circuit boards, the green boards dotted with chips, capacitors, and connectors. These PCBs are the treasure maps of modern electronics, hiding tiny but valuable amounts of gold along their pathways and pins. In a supergiant recycling facility, conveyors carry thousands of pounds of boards every hour, feeding them into shredders that grind the boards into small fragments, making it easier to extract the precious metals. Once shredded, the e-waste fragments undergo a series of mechanical separations. Powerful magnets pull out steel. Eddy current separators remove aluminum and copper. What remains is a concentrate of plastics and precious metal-rich material. This material is then ground into fine powder, almost like dust. Why? Because the finer the material, the easier it is for chemical processes to access the metals trapped inside. At this stage, the powder still looks like waste, but within it are flecks of gold, silver, palladium, and other valuable metals waiting to be reclaimed. Now comes the most fascinating and delicate part: extracting pure gold using chemistry. Traditionally, gold is separated using harsh chemicals like cyanide or mercury, but modern American recycling plants employ safer, more sustainable techniques. One of the most common methods is aqua regia, a mixture of hydrochloric acid and nitric acid that dissolves gold into solution. Here's how it works. 1. The ground e-waste is mixed into giant chemical tanks. 2. As the solution works, base metals like copper dissolve first, leaving behind the precious metals. 3. Gold, being more resistant, requires special conditions to dissolve. Once it does, it exists in liquid form as chloroauric acid. 4. To recover it, Engineers add reducing agents that cause pure gold to precipitate back out of the solution as fine particles. These tiny particles are then filtered, washed, and dried, leaving behind a brownish gold powder known as gold precipitate. The precipitate is not yet the shiny gold you imagine. It must be refined. The powder is collected and melted in high-temperature furnaces, reaching over 1,100 degrees Celsius. As the powder liquefies, impurities rise to the surface and are skimmed away. What remains is 99.99% pure molten gold. Workers carefully pour this glowing liquid into molds, where it cools and solidifies into gold bars, coins, or granules. Each bar is stamped with its purity and weight, a mark of value recognized worldwide. It's astonishing to realize that this bar, worth tens of thousands of dollars, came not from a mine deep in the earth, but from old smartphones and computers that people once tossed away. Gold recycling is more than just profitable, it's vital for the planet. Extracting 1 ounce of gold through mining can produce over 20 tons of toxic waste rock. By contrast, recycling requires far less energy and reduces greenhouse gas emissions significantly. However, the process isn't without challenges. Handling e-waste involves toxic substances like lead, mercury, and brominated flame retardants, which must be carefully managed to avoid harming workers or the environment. That's why modern American facilities use advanced filtration systems, closed-loop chemical processes, and strict environmental standards to ensure safety and sustainability. Globally, only about 20% of e-waste is properly recycled, meaning that mountains of valuable materials are still being dumped or burned, releasing toxins into the environment. The US, however, is home to some of the largest and most advanced e-waste recycling plants in the world. These facilities not only recover gold, but also silver, platinum, copper, and rare earth metals, essential for building new electronics, renewable energy systems, and even electric vehicles. As demand for technology grows, the importance of this industry will only increase. In fact, experts predict that by 2030, the value of urban mining, recovering metals from waste, could surpass traditional mining in certain sectors. If you found this journey fascinating, make sure to like the video, subscribe to the channel, and hit the bell so you never miss another deep dive into the world's most mind-blowing industries. Thanks for watching, and remember, the next time you hold a smartphone in your hand, you're holding a little piece of gold.